Hi everyone and welcome back to PrepFusion. I'm Anish and today we'll start the lecture 1B of this electromagnetism chapter. In the previous lecture we learned about what are magnetic fields, and we derived expression for a magnetic field, magnetic flux density due to a long current carrying wire. Okay, so I gave you a lot of homework, so all those questions we'll do, and also we'll derive in today's lecture few expression for what will be the magnetic field at the center due to a regular polygon. Also, we'll find out the magnetic field at the center along the axis of a current carrying loop, and obviously we'll do more questions on these things. Okay, so let's go back to the previous homework questions. So we'll go one by one, we'll do it one by one. So this one was the first question. This one is a good question. A horizontal overhead power line is positioned 4 meters above the ground. So a horizontal covered power line, let's say this is the line, right, which is carrying some current, and it is positioned 4 meters from the ground, right? Height is 4 meters. Okay, fine. Now next, what they are telling? So they are telling me that and carries a current of 100 amperes. So it carries a current of 100 amperes from east to west. Okay, from east to west it carries a current of 100 amperes. What I will do is, actually west is generally on the left, so I will write west on the left and east on the right. Okay, just for my convenience. Okay, so it is telling me it is carrying current from east to west. So east to west I will go. So this will be, current will be in this direction. Okay, now calculate the magnetic field directly below it on the ground. So if I am calculating directly below here, what will be the magnetic field? In which direction will the magnetic field? Now remember, if it is east to west, right, north will be in this direction and south will be in this direction, right? Like towards me, out of the plane of the wire, towards me, I am the south, and if I am looking and behind the wire, right, it will be north direction, and up is sky. This is sky, right? Top is sky and bottom is ground. Okay, I hope you get this point. So this is my ground basically, right? And towards me, in front of the wire, I am the south. Okay, and behind the wire is the north basically. I hope you know better about directions. Okay, and east should be here on the north and west should be here. Okay, that's why I written it like this. Generally, this is how we remember the directions. Okay. So what are they asking? They are asking me, calculate the magnetic field directly below this wire. Will the magnetic field be towards me, coming towards me, or outward, going into the plane? Where it will go? So just simple direction test I will do. I will use my thumb along the direction of the current. Okay, and then I will curl my fingers. If I curl my fingers at the top, I am seeing it is going out from me, so it is going into the plane, and in the bottom of the wire, it is coming towards me. So it is coming toward the south. So I can say the direction, EB cap direction will be what? It will be in the south direction. Okay, or if you want to write in terms of cross or dot, as it is coming towards me, arrow is coming towards me, that means I am just seeing a small point, small nip, so it will be dot simply. Okay, that will be the direction. So the direction has been cleared. Now obviously we'll discuss about the magnitude. So it is telling me calculate the magnetic field directly below it on the ground. So the point is directly below on the ground. This is the point that they want to calculate the magnetic field. So what will be this? I know the formula, right? What is the formula for infinitely current carrying wire? This is the infinitely long current carrying wire, because here they have mentioned overhead power transmission line. So transmission line is very long. Obviously I cannot find the end. There is some end obviously, but I will assume it to be infinitely long, because compared to this distance it is very large. So I can directly say here that BP will be mu naught, as this is in the they have not mentioned any medium, mu naught I upon 2 pi r. Okay, I am talking about the magnitude. Direction I have already mentioned. So it will be simply 2 into 10 raised to power minus 7. I is 100 amperes into 2 pi and 4 pi I have cancelled already. R is 1 by 4. Okay, so this will be 1 by 2, 55 nano Tesla. Okay, so this will be 5 nano Tesla. In what direction? In south direction. Okay, in south. So here it will be 50 nano Tesla or 5 into 10 to the power minus 6 Tesla northward, south. So these two options are anyways eliminated, right? Direction, according to your direction, these two options are anyways eliminated. Only this and this can be the viable options. Out of these two, I can see, okay, this should be C and D. Okay, sorry for that. This should be actually C and D. Okay, so out of these two, only option C can be correct. Why? Because this is 5 into 10 raised to the power minus 6, right? The magnitude is same and direction obviously southward. That is that I have already explained at the starting of this question. So I hope you understood this question and how to derive all the directions. Let's move on to the next question. So if I move on to this question, this is a finite current going over, is shaped as shown below. It is shaped as shown below. Determine the magnetic field at a point P located at a distance L from the wire. This is not infinite anymore. So this is finite. So I know one of the angle that the wire subtends with respect to the point P, that is 45. What is the other angle? Other angle is simply 90. So this is also pretty simple for us to do. Not that difficult, right? They just want me to find the magnitude. And what is the direction? Direction also I will say. Direction is again arrow cap direction and it is going into the plane. Going into the plane. So here the electric field will be what? Electric field formula at point P, it is, I'm just mainly focused on the formula right now. I can talk about the direction as well. I will talk about the direction here itself. So again, you put your fingers up, your finger is up and you curl your other fingers, right? Thumb, you put your thumb along the direction of the current and then you curl your fingers. What do you see? On the right hand side, it is going in the plane, right? It is going in the plane, right? So if it is going in the plane, it will be arrow cap direction, or what I can say, into the plane, cross direction, right? So this will be cross or A5, not arrow, sorry, arrow, A5 cap direction. Okay, and what is this value? This value will be, again, they have not mentioned anything about the medium. I will assume it to be like air or vacuum. So this will be mu naught, and have they talked anything about the current? Current they have also not told. So they just want me to find the expression only. Mu naught I divided by, this will not be 2 pi r, don't get confused, this will be 4 pi r. Okay, r is this L distance only into, what will the angle? One of the angle will be cos alpha. Cos alpha is 90. Okay, this angle is 90 actually, and this angle is 45 plus cos 45 degrees. So this comes out to be, this will be 1 by root 2. This will be 0 only. So this BP, right, will be mu naught I by 4 root 2 L arrow cap, or going inwards of the particular screen. Okay, so this will answer. These things are simple only, but here one interesting point comes. This one is pretty simple. Okay, but just the difference is this P point is not on one of the ends of the semi-infinite wire, it is somewhere in between. Okay, then the magnetic field expression will change a bit. Just with the help of basic formula that I derive, that one I will use. I will not remember any other formula, I will just remember that formula. So, and the second case is also very interesting. For the second case, I will show you like separately what will happen. So the first case, what is alpha and beta? Here, right, if you observe, alpha is obviously 0 because this is extending towards infinity. Alpha will be 0. Beta is 45. Beta is finite. Okay, this is not semi-infinite. Beta is finite. So my alpha is 0. Beta is 45. So I will use the same formula. And can you tell me what will be the direction of the magnetic field? It will be going inwards. Again, if I curl my fingers, right fingers, it will be going inwards. So my P will be simply mu naught I by, I value they have not given it. So I'll just assume mu naught I by 4 pi r. What is r? R is the distance. R is simply L in this case, into cos of how much? Cos of alpha is 90, cos of not 90, so alpha is 0 plus cos of 45 into direction is arrow cap or inwards, right? As I'm on the right hand side, it will be inwards, cross, simply going into the screen. This is not B arrow cap, this simply is B dash. So this is the expression. So this if I just write this down a bit properly, this will be 1 plus under root 2 plus 1, and in the bottom also I will have under root 2. So this will be mu naught I under root 2 plus 1 divided by 4 under root 2 pi L A phi cap. Okay, this will be the expression for this particular configuration. Now what about this configuration? This configuration is actually interesting because can you tell me what is the alpha and beta here? Okay. Can you tell me what is the alpha and beta? So here if I observe that from this end, right, this end, from this point, what is the beta basically? Beta is 0. Okay, beta is 0. But what is the alpha? What is alpha, you might ask? So here what is happening is that if I find out the angle between this point, one of the points, and this point P, it is 180. Correct? So here what is happening, I can show you. The angle, this is extending towards infinity. Okay, so this angle is simply 0, alpha is 0, but beta is actually simply 180, right? Beta is 180, so beta is 180. So even if I assume like there is some perpendicular distance here, that perpendicular distance is 0, but if I assume some perpendicular distance, okay, some perpendicular distance, if I assume some perpendicular distance, find it R0, if I find out the magnetic field due to this particular section, okay, B dash, BP dash, this will be what? This will be simply cos of 0 plus cos of 180, which will cancel out, right? 1 minus 1 will cancel out. So this will overall become 0 simply. This will simply become 0, and this is mu naught I upon 4 pi R. So if this becomes 0, so the magnetic field produced due to this particular section of the wire is simply 0. Okay, what about this section? Now let's come to this section. Yeah, this section has some magnetic field because this is L and this is 90. Okay, and this is extending towards infinity. So one angle is 90, other angle is what? Other angle will be simply 0, right? This will almost be equal to 0. They will almost be equal to parallel, so that angle will come out to be 0 almost. So for BP dash, this is for BP dash, for BP double dash, for BP double dash, what will happen? Alpha will be 90 and beta will be simply 0. So my BP double dash will come out to be what? BP double dash will come out to be mu naught I by 4 pi. What is the perpendicular distance? Perpendicular distance is simply L by 4 pi L cos 90 plus cos 0. And what is the direction? Now if I place my thumb along the direction of the current for the second section and curl my fingers, if I curl my fingers, the fingers are coming towards me. So it is coming out of the screen. So it is coming out of the screen. So if it is coming out of the screen, I will not write the direct vector format of the direction. I will just say it is coming towards me. If it is coming towards me, okay, this won't let me make a circle. That's the important point. I will just see a point. Arrow is coming towards me. I will just see the nipple, right? Nipple. Okay, so I didn't meant that. Okay, so don't put your words in the mouth. So yeah, so this is what I got. So what I will get the expression as my final expression will be magnetic field at point P will just simply be BP will be, for the second case, for the section 1 it will be 0, for the section 2 it will be mu naught upon 4 pi L and coming arrow coming towards me. Okay. So this will be the answer for the two cases. So let's now move, like here I have just written that point only in the notes itself, that magnetic field along the on the axis of the current carrying wire is 0, because either the theta will be simply, like one of the theta will be 0 and other theta will be 180. So whatever will happen, cos 0 plus cos 180 will always give me 0. Okay, that's why. So either theta will be one of the theta will be 0 or theta 2 or theta will be 180. Okay, these two things is possibility, not both at once. So let's solve it for this. So here this is not along the axis, right? I'm computing at the point P. This is again finite wire. So just I'm making the arrangements, and can you tell me the direction? So due to the section 1, if I place my thumb along the direction of the current and rotate my fingers, curl my fingers, I am observing it is going into the screen. And for the this section as well, if I place my thumb along the current and curl my fingers, I am getting it is again going into the screen. It is again going into the screen. So both of the magnetic fields due to each of the sections are actually supporting. Okay, so I will add these two as they are both supporting, as they are working in the same direction. Okay. So we'll compute this. This is not infinite, this is a finite thing, right? Because they have mentioned a finite current carrying wire of length 2L is bent in the shape shown below. It's just bent like a right angle triangle. Determine the magnetic field at point P, which is equidistant from both segments at a distance L by 2. So it is, what does it mean, which is equidistant from both of the segments? That means that vertically the distance is L by 2 from the rod, and horizontally also the distance is L by 2 from the rod. Okay, that is the perpendicular distance. So from there we are able to compute the perpendicular distance, and they have mentioned that this angle is 45. Okay, is this of much use to us? We will see. Okay, so this distance is L by 2 and this is L. Okay, this is total 90, so this will be 45. Okay, this is 45. If this is 45, right, what will happen? This angle will also be 45 because this angle is 90. Okay, this angle is 90, this is 45 and this is 90. So this has to be also 45 and this has to be also 45. So overall this will be 90. Actually these two will be 45 basically. These triangles will be 45. So like you can do the simple geometry. Okay, both alpha and beta in both the cases will be simply 45. I will just show you like how the geometry is working. So what is happening is this angle will be 45, right? Because this overall is 90. So this angle is 45. Now if I just draw a perpendicular here, I just draw a perpendicular, this angle is 90 and this angle is also 90. If this has a 90, this is 45, this is a triangle, this has to be what? This has to be 45 because the sum of all the angles is simply 45. Is simply 180, right? So now this is 90 and this, let's say, is some angle theta, or this, let's say, is some angle alpha. Okay, what will be this angle? This angle will be simply 90 minus alpha, right? If I have enough space, this will be simply 90 minus alpha. Why? Because this is 90, this is alpha, so overall sum will be 180. This will be 90 minus alpha, and this is L by 2, right? This thing is L by 2. And this is also L by 2 because this is just a perpendicular. These two angles are 45, so this also has to be L by 2 as mentioned here. As mentioned here, right? This is L by 2. So this is L by 2. And this is also L by 2, right? This will be L by 2. Overall, this is L only. And this is also L by 2. If the two sides of a triangle are same, right? Their angles will also be same, their opposite angles will also be same. So 90 minus alpha has to be equals to alpha. So alpha equals to 45. Like you can find it out many ways. There are many ways. This was one of the ways. Same case you apply here. This angle will also you will get as 45. Okay, simple geometry. So what is happening is that my overall magnetic field P will be sum of two magnetic fields BP dash plus BP double dash. Okay, due to this and due to this section and due to this section, both are separate in their finite elements, and like both have perpendicular distances L by 2, and alpha beta are same for both of them. So basically both have alpha equals to beta equals to pi by 4 and r equals to L by 2. Perpendicular distance is same. So what will happen, BP will be, and both are additive in nature, it will be 2 times BP dash. What is the direction? Direction is piercing in the screen, right? It is going in the screen. Okay, so it will be a cross sign into the screen. 2 times mu naught I by 4 pi L by 2 into cos 45 plus sin 45, sorry, cos 45 plus cos 45. So this will be root 2, basically 1 by root 2 plus 1 by root 2 becomes root 2. So this is root 2. So in the bottom I will have a 2 root 2. 2 gets cancelled. This is 2 cancels. Only root 2 is at the top. So what I will get? I will get root 2 mu naught I divided by pi L. Okay, and it will go into the screen. It will go into the screen. That will be simply the direction. Okay, so that this is the solution for this question. This question is simple. Just you have to identify the angles with bit of geometry. That is the important portion here. So we'll start this question. A finite current carrying wire is shaped as shown in the figure. Determine the magnetic field at a point P located at a distance L from the wire. Okay, here, right, actually there are 3 sections. This is one of the section, this is another section, this is another section. This is a finite carrying wire like this. Now can you tell me due to this and due to this, will there be any magnetic field? No, right? There is no perpendicular distance. So I will just say here, in short, the summary of this is, mainly I told you, right, the current gets produced if there is some the perpendicular component of current is present. So if perpendicular distance is 0, or here I've written the same thing, right? If magnetic field is on the axis of the current carrying wire, then it will be simply 0. Magnetic field will be simply 0, right? So it will be simply 0. If perpendicular distance is 0, then B will be simply 0. That's the one thing that I wanted to share with you. Okay, so here if I observe that this point, right, this doesn't have any perpendicular component, right? This is on the axis. If I extend this wire, this point lies on the axis. So due to this also, the magnetic field at point P will be 0. Let's break this down into 3 sections. Okay, don't worry, how will you know if it is on the axis or not? You will understand by seeing the diagram. Okay, if I break it down into 3 sections, here I have section 1 and section 3, and this is the section 2. So I'm observing section 1. If I extend it, it passes through point P. If I extend the section 3, it also passes through point P. So obviously the magnetic field due to 3 and 2 will be 0. So magnetic field B1 equals to B3 will be 0, but B2 will be non-zero. So what will be B2 basically? For finding out B2, again we have to find out alpha and beta, and in which direction is this time the magnetic field is. If I just rotate, if I just put my fingers along the current, and if I curl my fingers, I see it is coming towards me. So this time it is dot coming towards me. So here I can observe this is 30 degrees, right? So this angle will be 30 simply. So as this whole angle is 60, so this angle will be 30. Now another thing is, this total is 60 and this is a triangle, right? It is a right angle triangle. This is 60, so this angle will be 30 simply. Okay, again this is a triangle, not a right angle triangle, but this is a triangle, right? If this is 30, this is 30, this has to be 120. So this angle will be simply 120. Okay, just with the help of geometry I am able to do all this. So bit of geometry knowledge also you should have. Okay, so I can say that my alpha is equals to 30 and my beta equals to 120. Okay, and direction is, what is the direction? Direction is coming towards me, so it will be dot coming towards me, right? If I curl my right hand, it will come towards me. So here I can say that this B2 will be simply the B net. Okay, this will be equals to, now what is the distance actually? This distance is L. So this perpendicular distance from the axis of the current carrying wire, what is the perpendicular distance? It is simply L. So this will not change. This is still L, right? This will not change. So this will be L only. So this will be mu naught I divided by 4 pi L. And don't worry, I will like tell you a shortcut to find out the current magnetic field for an infinitely long wire with the help of a similar law, just like Gauss law. Okay, that we will learn later on. 4 pi L into cos of 30 plus cos of 120. And this, sorry for the noises, it is just currently Diwali is going on, so that's why there are few noises. I will soon stop the recording because a lot of firecrackers will burn now. So this will be equals to mu naught I by 4 pi L cos 30 is root 3 by 2, and this will be minus 1 by 2. Okay, this comes out to be mu naught I by 8 pi L root 3 root 3 minus 1, and it will come out. It will come out of the screen, right? It will come towards me. Okay, so this will be the direction and this will be the magnitude basically. So another similar question, like these type of question, there are many these type of questions, and this can come in GATE examination. They can ask any these type of configuration. So I am preparing you for everything. So again, a finite current carrying wire is shaped as shown below. It is not finite actually. This is infinite. This also is kind of infinite only. So the wording is a bit wrong. It should be infinite. This also is infinite. Okay, so can you tell me what will be the magnetic field at the origin? Okay, so again, if I observe that this is not lying along the axis, right? Here the axis of this particular wire is this, so obviously it has some perpendicular distance. This also is not lying along the axis. This also has some perpendicular distance, and this wire also has some perpendicular distance. So it is perfectly fine. Here magnetic field is not zero. So we'll divide it piece by piece. So I will just copy this circuit. Okay, copy this thing, paste it over here, and delete this and reduce the size of this a bit. So what is the, like, I can break this down into 3 different sections. So this is the section 1, section 2 and section 3. Now if I observe carefully, the perpendicular distance due to the section 1 is what? This is the perpendicular distance, right? Yeah, sorry for that noise. This is the perpendicular distance, so this will be the perpendicular distance basically. I can observe this will be the perpendicular distance. And what is this distance basically? If you observe from the x axis how far I am on the z plane, right? This wire is on the xz plane. Okay, this wire is on the xz plane. So what is this distance? This is the how much I have moved from the xy plane, right? Along this axis, how much I have moved? L. So this perpendicular distance will be L, and this distance is again easy to look at. This distance is also what? From this particular plane, how much I have moved, right? How much I have moved? L distance. Along the x direction, how much I have moved? L distance. So this is again L. Again, the same thing applies here as well. So this is the particular plane. From the xz plane, how much above I have moved? How much have I moved? I have moved along y axis. How much? Y L distance, right? This is again, okay, sorry. This is again L distance. Okay, so if this is L, so this all these three things are L only. So perpendicular distance, okay, not this actually, sorry, not this, this distance, this is not the perpendicular distance. This is the perpendicular distance, right? This thing is how much? This thing is from this y z plane, how much have I moved in the x axis? That is x. So this will be L. Okay, basically simple. Everything is L. All the perpendicular distance are L. Now what about the angles? So for this case, right, origin is lying here. So for this particular case, this is 90. So one of the angle will be 90. And for this particular section, it's section 2, one of the angle is 90. Okay, angle that the perpendicular distance makes with the basically wire. Okay, and other angle is what? This angle, again this angle, this has some angle, right? So I have to draw all the angles. So if I draw this particular thing, right, this r vector, what will be the angle now? Just use some different color. This angle will be how much? This angle will be how much? Now this is L, and this also is L, right? This is L and this also is L, although diametrically this doesn't look like that. Like in the diagram it doesn't resemble these two sides are equal. If these two sides are equal, right, the angles also will be simply equal. Okay, and what will be the angle? This is 90 degrees, so the other two angle has to be equal. So 2 theta plus 90 equals to 180. Sum of angles in a triangle is 180, so theta will be 45. So both these angles will be 45. This angle will be 45. Okay, what about this angle? One of the end is infinity, right? So this end is infinity, but this end is 90. So it becomes simpler only for me to compute the angle. So I will calculate this separately. Okay, now and for this what will happen? For this particular section what will happen? So if I observe for this particular section here, this is the angle. This angle is 135 actually. This angle is 135. Why? Because this is 90. This is 90, right? And overall angle from the line segment to the r vector, okay, 135. So one of the angle is alpha is 135, other angle is simply 0 because it is going towards infinity. So angle, if it is goes towards infinity, is 0. So for section 1, I will write one by one. Section 1, my alpha will be 90 plus 45. Why 90 plus 45? This is 45 and this is 90, right? So I have to compute that was the definition of alpha, angle between r vector and this line segment, current element, right? It was total this, so 135. So this will be 135 degrees. What about beta? Beta is 0 because infinity, other end is infinity, so beta is 0. So from now we have to talk about the direction as well. So I am observing that due to this section 1, now if I curl place my thumb along the current direction and rotate my fingers, it is along minus ay cap. It is going downwards, right? It is going downwards. If I curl my fingers, it is going downwards. So direction will be minus ay cap. So I can directly write this, that V P1, this will be mu naught I upon 4 pi. Distance, what is the perpendicular distance? It is simply L. L into cos of 135 plus cos of 0 in the minus a y cap direction. So I haven't talked about direction yet. Now I am talking about direction. Minus a y cap in the downward direction. Okay. Now what is the thing about section 2? In section 2, what I can observe is that this simple only. One of the angle is 90. This is the r vector, right? And the angle between the current segment and this vector is 90. Other angle is 45, right? This is the r vector and this is the current segment 45. So in the section 2, I can say alpha is 45. You can choose anything, alpha, beta, that doesn't matter, and beta is 90. So again, now what is the direction here? I can observe that this is in the plus ay cap direction. Just place your finger along the current and just curl the other fingers, right? Place your thumb along the current and curl your other fingers. What do you observe? You are observing that it is in the going upwards, right? Going upwards in the plus ay cap direction, right? In the plus ay cap direction. So I'll just directly write down the expression Vp2 mu naught I upon the perpendicular distance is again L, and this is cos 45 plus cos 90. So one of them will be 0. So this will be 1 by root 2 only. So this I can write directly here, 4 root 2 pi L plus ay cap direction, right? I hope this point is very important. The direction is very important here because few things will get cancelled out. So section 3, we will move to section 3 now. So what about the section 3? Section 3 is Vp3. So Vp3 will be simply mu naught I. Again, what is the alpha and beta here? If I observe, one of the angle from this point is 90, other is at infinity. So that will be simply 0. That will be simply 0. So here again, alpha is 0 and beta is 90. Okay, so this will be due to like the semi-infinite case. So mu naught I by 4 pi epsilon L. Okay, this will be the answer. In what direction? Again, if I observe, this is in the ax cap direction, right? Not ax, sorry, az cap direction. If I just place my finger along the current and just rotate my finger, this is in the az cap direction, right? Az cap direction. So this will be in the az cap direction. So what will be the final magnetic field? Vp. It will be simply, I will take mu naught I by 4 pi L common. Okay, if I take this thing common, right? Yeah. This will be, yeah, sorry for the noise. I will soon finish the recording so you don't have to listen to the noise. I just want to complete this particular section. So this will be minus 1 by root 2. This will be okay, this is in the minus ay cap anyway. So this is plus 1 by root 2. Here I have this becomes plus 1 by root 2. This becomes plus 1 by root 2, and this is again minus 1. So overall this becomes root 2 minus 1 ay, and this is nt plus ay, yeah, plus az cap. Okay, so this is the expression, and along with direction that I get my final answer. So just be careful about the directions. Okay, just how to add them. So I hope I have explained everything clearly. So now for few common polygons, how will you derive the expression? For square I will do. For the others I will just derive a formula, and I will tell you how to remember that formula as well. I will derive the formula in front of you. Okay, so if I observe, due to this square, okay, this side is L, so I will place my fingers and I am observing it is coming out of the screen, right? If I am placing my fingers along the current direction and curling my fingers coming towards me, due to this, placing my fingers and curling my like placing my thumb here and curling my fingers, only use this with the right hand, right? So curling, it is again coming towards me. This also if I place, it will again come towards me. this will also come towards me. So all of them are additive. So whenever current is in a loop, right, they will be simply additive. Okay, all the magnetic fields will be simply additive. Okay, they will not like one magnetic field will be in other direction, another magnetic field will be in opposite. No, they will always be in additive. Okay, so what will happen, as this is a symmetric case, due to all these 4 sections, right, all 4 sections, I will just simply multiply 4 because the magnitudes of all of the magnetic field will be same, and I will just simply add. So if I just take this first case, this is just same as the finite current carrying conductor case, finite length, current carrying conductor of a finite length. Okay, but what is the difference here? The difference is I have 4 finite current carrying conductors, and each of them has angles of what? Angles of 45. Why is this 45? Because this whole thing is 90 and this will be simply angle bisector. You can do it like that as well, or you can understand with simple, this side will be L, this will be L, this will not be L, this will be this whole diagonal will be root 2 L, this will be L by root 2, this will be L by root 2, as the 2 sides are of same length, so the angles will also be same, that is 45 degrees. So obviously the perpendicular distance is what? L by 2, right? Perpendicular distance is simply L by 2. Okay, so this distance becomes L by 2. So obviously I will just calculate the current like the magnetic field due to one of the fields, and I will simply multiply that for B1, right? That I will do because all 4 of them are additive. This for the part 1. So what is B1 basically? B1 is mu naught I upon 4 pi perpendicular distance, which is L by 2. This is the perpendicular distance, right? It is half of this, right? So this will be L by 2 plus alpha beta. Alpha is 45 and beta is 45. For all the 4 cases, you will just see, you can do it by yourself, it will be 45. So simply it will be 1 by root 2. I'll just write here properly actually. Cos of 45 plus cos of 45. So this simply becomes 2. Okay, 4 gets cancelled here anyways. This 2 gets cancelled, and 1 by root 2 is still there. So it will become mu naught I by under root 2 pi L. Okay, this will be the answer. And the direction is what? Direction is always going into the screen. Oh no, not in, out of the screen. Coming out of the screen, right? This is coming out of the screen towards me. So it will be a dot. Coming out of the screen, simple dot. Now, can you derive it for other cases as well? So what I will do is, let's say I have a pentagon, right? Can I derive something for this? Okay, without going in too much in depth. How do I derive? Mainly what I need to find out is the angles, right? And these angles will be symmetrical. Okay, these angles will be symmetrical. So what I need to find out is, if I just place this, okay, this theta angles I need to find out. That's it. That's the thing that I need to find out. So how do I identify these angles? How do I find out these angles? So this angle will be basically, this will be the if I just draw a line from here, okay, I will just derive the formula. It's okay if you couldn't understand the derivation, but it's good if you could, because that will help you immensely while remembering the formula. So overall this distance will be L by 2, right? And this also will be L by 2 simply due to symmetry. Everything is symmetric here. Now, what is this angle? How do you find out this angle? So what I can do is, this angle I can name this as any other angle, as phi or something, okay, and there will be how many of this? How many of the sides are there? So there are 1, 2, 3, 4, 5. If there are 5 sides, right, there will be 5 phis. So if there are n sides here, there will be n phis, and the summation of all of them will be 360, because this is a total circle. Okay, so it depends on the number of sides. So this will be n phi equals to 360. This is one relationship that I get. So phi equals to 360 divided by n. Okay. Next, I want to find out theta, because with the help of theta only I will be able to comment on alpha beta. They are same only. so that I will be able to write the formula in the formula. So what is my theta? So theta will be simply 180 minus phi divided by 2. So this will be simply 90 minus phi divided by 2. And what is phi? Phi is actually 360 by n. That I will put later on. Later on. Okay, don't worry about that. So can I put in the formula now? What was the formula? It will be, in the formula what I can put is magnetic field BP will be what? It will be simply, as it is a symmetric case, I will do, as there are n sides, it will be n times that. Previously there were 4 sides. That's why I multiplied 4. Now there are n sides. I will multiply n with one magnetic field, right? And the direction, direction you can understand with the help of simple curling of the fingers. This will be equals to what? B1 will be equals to what? N times B1 is what? B1 is mu naught I by 4 pi perpendicular distance, and perpendicular distance will always be some distance d they will give you, okay, and that distance will be symmetrical. That distance they will give you. Don't worry about that. That distance they will give you. This d distance I will assume. So here as well, okay, I haven't mentioned the distance. You can find out this distance as well with the help of theta and all those things, but I'm not into that right now. I'm not calculating that. You can find out that as well. I will tell you how you find out that as well. I will explain that as well. Just 1 second, okay. So I just wanted to write the formula right now. This is equals to cos of alpha and beta. What is alpha? Alpha is theta, beta is theta. And what is theta? Theta is 90 minus phi by 2. And what is cos? 90 minus theta. Simple sin theta, right? So this will be sin phi by 2, 2 into sin phi by 2, right? So this will become, like I can say here, I will write here perfectly, cos of 90 minus phi by 2 plus cos of 90 minus phi by 2. Okay, and direction is in the A B cap direction. Okay, so if the direction is in the A B cap direction, so that you can identify with your fingers. So here this will become 2 and this will become sine. And what is phi by 2? Basically phi by 2, if I put it here, it will be 180 by n. 180 by n. Okay, so your BP comes out to be n times mu naught I divided by 4 pi d sine 2 gets cancelled, so this will be 2 only, 2 sine 180 divided by n. Okay, now how do you find out d? So d also sometimes they will not give you. How do you find out d? So d, for the pentagon case, can you find out d? For this case, how you find out d? You just use the diagonal formula, but here we cannot use the diagonal formula. What I will do, I will take help of this triangle again. So this will be L by 2, and this theta and phi, all those things I know, right? So if this is L by 2, can I write d? So I can simply write the d, right? So this d will be, if I do, this is a simple bisect, right? This will be phi by 2 simply. This will be phi by 2. So d will be, I can write out, like I'm thinking of few ways, like how I can write this. There can be many ways you can find out d, but one way will be, if I just use this triangle, this is base and this is altitude. So altitude upon base will be tan of this theta, and theta I know. Theta is what? Theta is this thing, correct? Theta is this thing. Okay, so I can write down d. D will be just hold on, tan theta. Tan theta will be height upon base, L by 2. Okay, L by 2. So what is tan theta? Tan theta is 90 minus phi by 2, correct? So it will become cot phi by 2. Cot phi by 2. And what is cot phi by 2? What is phi by 2? Phi by 2 is 180 by n. So it will be cot 180 by n. Okay, and into L by 2 is obviously here. 180 by n into L by 2 equals to D. So if I just replace this cot 180, what is cot 180? It is cos upon sine. So what happens? Sine, okay, sine and sine will not get cancelled here. Okay, sine and sine will not get cancelled. So they will remain. So like you can just replace this thing over here, okay, with the in place of D, and from there you can get the answer. Okay, so like I'll just put this D value on the left hand side. That looks better. So I have told you how we can derive this value for D as well. Most cases they will give you D. Even if they don't give you D, you can derive with the simple trigonometry, right? Okay, this can be pasted over here. Like here I have just written the formula. Okay, what are the things you should know? D also I have written it. If they don't give you D, you can find it out. Generally they will give you the D. Okay, L if they don't give, then they have to give D. Something they have to give, right? So with the help of this, can I derive the expression for this particular 1, 2, 3 hexagon, for this hexagon? So here I can use the formula, or I can directly write it down. Okay, that what will be the, for the second case, right? I have just derived what will be the magnetic field. It will be simply, I will use this formula. It is 6 times mu naught I divide by 2 pi into D. What is the D in this case? For a hexagon, what is the D? I can use this formula, or I can directly use, I will put here. So it is simply, if I put 6 here, it is cot 30. Okay, what is cot 30? Cot 30 is 1 by root 3, right? Cot 30 is cot 30 is root 3. Cot 30 is root 3. So this will be into L by 2 root 3. Okay, and in here, like I have derived, you can derive it as well, or you can put directly in the formula. This will be sine 30. Sine 30 is 1 by 2. So this one will come out to be 3 mu naught I. Okay, and 2 will get cancelled. Root 3 is still at the bottom, so root 3 will be at the top. Okay, so it will be root 3 mu naught I pi L. And what will be the direction? It will be again in the plane, right? Here if I see, it is clockwise direction, so it is not in the plane, so it is coming outside. So there is another simpler way to find out the direction of magnetic field for a loop. I will talk about that in today's lecture, but for now just try to understand that if I just draw if I just follow my fingers, it is like what? If I just follow my fingers and it is coming towards me, again it is coming towards me, so it will be pointing outwards. So this will be the solution for this particular question. This will simply point outwards. This will be towards me. Okay, and this is the expression that I told you. You can remember this. I have written it like this, so that it's easier for you to remember. I can directly write this sine theta formula, all these things. Okay, I have seen notes of other educators and they just directly write this formula sine theta. They don't tell you how this formula is. Okay, so I have derived this as well for your convenience, so that you can remember this. So this is how you should make short notes. You should make short notes by putting this formula, so that you can understand why each term is there. So it becomes easier for you to remember. And once in the examination hall, even if you forget, right, you will understand why that term was there, and it will be easier for you to recall. Okay, so this was the expression for this particular thing, for this regular polygon. If it is a regular polygon of n sides, I can easily find out the magnetic field at the center. This is only valid for the magnetic field at the center, not at any other place. Okay, so this is symmetrical, that's why. So now we'll start with today's lecture basically. So before starting today's topics, right, I wanted to go through one more question. So I just added one more question to get more clarity over the concept of magnetic field due to a infinite line or a semi-infinite line. Okay, so because there I wasn't talking about r vector, here we will talk about the r vector, the position vector, and exactly what will be the direction of the field. So let's read this question together. A semi-infinite line along the positive y-axis from the origin carries a filamentary current of 2 ampere. Like I hope you don't understand filamentary, so I'll just remove the filamentary. That's not that important. Carries a current of 2 ampere in the AY direction. Just hold on. In the AY direction. Okay. Then what are they asking? They are asking determine the magnetic field at point 3, 12, -4. If exact point is given and the direction of the current is also known, exact direction of the current, then how do I compute? That I will show you. Okay. So first of all, they have told me that the current flows in the -AY direction and it's a semi-infinite line along the positive y-axis. So if I just draw the XYZ, So here, let's say this is x, this is y, this is z. So my wire will be on the positive y axis, because positive y means there is a end point at origin, but the other point is infinity. It is semi-infinite wire, right? So my lamp will lie on the positive y axis. Okay, this is infinity. So what I can say is this carries a current of how much? This carries a current of 2 amperes. Okay, as this is in the minus AY cap direction, they have mentioned that the current carried is in the minus AY cap direction. Now, why is the point? So I can just write down the point. It's not that important to identify where exactly is the point, because the position has been given in terms of coordinates. But still, if I want to say where is the point, here I am observing that the point is 3 plus 12. So it is on this positive side of xy plane, and minus 4. So behind the screen, right? Behind somewhere here. So the point will lie somewhere here. Okay, this is not the exact place, but like somewhere approximately the point will lie here. Now, how to find out the perpendicular distance? How do I find out the perpendicular distance? Just you identify the wherever this is residing, right? The coordinate must be equal to each other. Then only I will be able to find the perpendicular distance. What do I mean by that? So if I just draw a straight line that is 90 degree through this. Okay, so I have to draw a straight line that is 90 degree through this, and that will give me what? This r vector. Okay, so how do I get this r vector? So what I can say is that few components must be same. What is the direction of this current or dl vector? Dl vector direction is minus ay cap, correct? Minus ay cap. Now, as this is normal, then its y cap component must be same. Okay, its y cap component must be same. So what I can say is this. What will be this point? As it is normal, right? As it is normal to this, the tangential components will be different, but the normal components will be same. What do I mean by that? This. So here, as this is lying around the y-axis, my normal component is what? Is the normal component is something else, but this is lying on the y-axis. So if it is lying on the y-axis, what is the y value? Y value is 12. As it is a straight line, here also it will be symmetrical, and y will be 12, and all other coordinates will be 0 simply. Okay, all other coordinates will be simply 0. Now, you might say, what if the position of this line, right, is something else? Let's say the position of this line is 3x plus 4 ay. I'm talking about the direction. Okay, so what I will say is that this position is fixed, right? The z component is varying. So whatever is the other remaining component, that component will be equals to this component. Okay, that z will be equals to z. Then only I will be able to find the distance. Because remember, in the lecture 0 prerequisites chapter, I told you at least one parameter needs to vary to get a 1D structure, because this line is a 1D structure, right? So one component needs to vary. Here actually what is happening is what are the two things that are fixed in this particular section? What are the two things that are fixed? Here my z and x are fixed. What is z and x for this line? 0, 0. So for this line, can I write down the like equation? It is x equals to 0, z equals to 0, and y equals to y, because y is varying from infinity to 0. So what will I make equal here? What is the variable? Y is the variable, right? So that is what I will make equal. Okay, I hope you understand the point. Whenever they will give you the line, okay, the fixed point, you don't make it equal. That will give you the tangential component. Just make the variable equals to the that same axis here. Okay, whatever is the variable, let's say z was variable, I would have made z equals to minus 4, and I would have find out the distance. So now what will be my r vector? So this is my, let's assume this has some position x. So x will be equals to what? X will be always equals to 0, this y will be same as this 12. Okay, So my ox vector is 0 comma 4 comma not 4, sorry, 0 comma minus 12 comma not minus 12 again, 0 comma 12 comma minus 4. So now I can say that this will be OP, R vector will be like it should go outwards of the point P, right? So it will be OP minus OX. So this will be equals to OP is 3. I'll just write it directly. Basically the 12 will get cancelled. This will be only remaining. So it will be 3AX minus 4AY. Okay. So this will be the R vector. But I need to find AR vector because I just want to find the direction, unit vector along this direction. AR vector. AR vector is 3x minus 4ay divided by under root 5. Okay, that's basically it. Or not under root 5, sorry, simply 5. That is the magnitude. Now what is the formula, if you remember? What was the formula due to a semi-infinite bar? So we have to find out the angles, right? We have to find out the angles. How do I find out how do I identify the angles? This also is an interesting task. So I'll just take this in the next page. So now if I just cancel this R is not required anymore. Okay, I need to find out angles. So one of these angles will be simply 0, right? This is the beta, and beta equals to 0. That's pretty simple. But what about this angle, alpha? How do you find out this angle? This is simply a triangle. If I just connect these points, right, this is the magnitude of R vector, that is equals to my 5. Magnitude of R vector will be 5 simply. And this side, I know this side. This side I can easily find out what is the distance of this side, right? What will be the distance of this particular side? Any name you give, like OP magnitude. This will be magnitude of OP simply, right? So what is the distance of this particular side? I will find out, and with the help of this I will be able to find out alpha, because this is 90, this is 90. Okay, so I will get the relationship that, okay, do I know anything else? Okay, this height I already know, right? Okay, I don't even need to find out this OP. Why I don't need to find out OP? Because I already know the magnitude of OX. I already know the magnitude of OX. What is the magnitude of OX? What was OX equals to? 0 comma here 0 comma, okay, this is again, okay, I've even written wrong here, sorry about that. OX should not be minus 4. OX is 0 comma 12 comma 0. Sorry about that. So yeah, I'm sorry about that. So this magnitude is simply 12, right? OX magnitude is simply 12. Okay, so now I can simply write this expression that what is my this is tan alpha, right? What is my tan alpha? Tan alpha will be altitude upon base. So altitude is magnitude of R divided by magnitude of OX. Magnitude of R is 5, magnitude of OX is 12. So your alpha actually comes out to be 37.13 degree. Okay, so this is the value of alpha. Now we can proceed further. We got the alpha, we got the beta. So what was the formula? First I will write the magnitude of the magnetic field. How do you find out the magnitude of the magnetic field? It is simply mu naught, as nothing is mentioned, I will assume it to be free space, 4 pi the magnitude of the distance. What is the magnitude of the distance? This perpendicular distance, that is 5. So magnitude of R into cos of alpha plus cos of beta. Okay, direction I'm not concerned about right now, but direction also I can directly write, right? What is the direction? Direction will be this. Will it be this? No, it won't be this direction, right? It will be simply what? If you remember, this was the magnitude and the direction was dl ideal cross AR, correct? If you remember it correctly. So this is the direction basically. What is the direction of dl? Along the direction of the current, it is minus ay. So I will write here what is the direction of dl. Yeah, I have written here, right? Direction of dl is minus ay. So I will just replace with minus ay here, and I will replace this ar with this particular thing. Okay, so I will do all these substitutions. This is the magnetic field at P. So the magnetic field at P will simply be mu naught I by 4 pi. I is how much? I is 2 amperes, right? I is simply 2 amperes. So 2 into 5 into cos of 37.13. Cos of 37.13 is simply 12 by 13 plus cos of 0. Cos of 0 will be 1 into dl is which direction? Minus ay cap cross ar cap. Ar cap is in which direction? 3ax minus 4ay divided by 5. So this will be this will be how much? So this is 4 pi, right? And this is also 4 pi. This will be 10 raised to the power minus 7 into 2 by 5 is still there. So this is 2 by 5 into 25 by 13. And what will this become actually? If I do minus a, like y cross ax, right? This will become actually minus az. So which will make it plus az actually. Plus 3az and y cross y will be simply 0. Okay, okay, sorry, this is, okay, again I have done some mistake. This should not be y, right? I don't understand why I'm making so many mistakes. Sorry about this. This will be simply z, right? Because what is my OP? I'm really sorry. So my OP is simply (3ax) plus 12 ay minus 4 az. So this is my OP basically, right? Okay, so now here this will be az. I'm sorry, this will be actually az. So if this is az, this is az. So like just be careful about this in your exam as well. You can do this silly mistake. Just check whether you are making any silly mistakes or not. Now this minus a minus a cross y, this will become plus 4ax divided by 5. So cross product I hope you are able to do. I will not explain that one. Okay, so here what does this become? So this becomes overall 5 due to this 5 due to this 5, this gets cancelled. This will be 2 by 13 into 10 raised to the power minus 7 4ax plus 3az. Okay, in Tesla. Now this will be the electric field expression actually, and this is a very good question. Okay, try to understand this perfectly. So I hope you understood the point how I assume the perpendicular direction. What I did was, I know we have studied in basics that I have to get a 1D structure. For me to get a 1D structure, at least one coordinate needs to vary. So either y will vary, z will vary, or x will vary. Whichever one varies, I will equate that with the given point. Okay, that coordinate will be same. So let's say x is varying, so I will equate that with 3, and the remaining 2 I will take. So I will subtract the remaining 2. Okay, so this position R, they will give me this point. These 3 things they will give me. What is varying? Y is varying, xy is varying, or z is varying. So let's take for example here, if the wire was lying somewhere around here, okay, like this, x1 2. Now what would have been the perpendicular distance? Now what I would have done is made the x same. So x would have been same now. So x would have been equals to 3. So that r vector would have been what now? R vector would have been simply this vector would have been same. So this would have been 0ax plus final, that is 12, minus initial, that is 1, 11ay minus plus again plus final, that is minus 4 initial 2. So final minus initial minus 6 ay. Okay, az. So I hope you understood this point, that what am I doing. So I have quickly gone through the step. The perpendicular distance is the most important thing. Once you find the perpendicular distance, then just you apply this simple law that this will I know the coordinates of this particular perpendicular bisector, right? So if I know the coordinates of this, then I can simply find out the length of this one of the sides, and if I know the length of one of the sides, I can simply find out the angle as I have calculated here. So that's how you solve this question if the exact position is given. If the exact position is not given, just find the magnitude, and using your right hand rule you can find you can discuss about the direction. Okay, so that was it basically for this particular question, and this is a very good question. Now let's move on to next question. Okay, so let's do this question, let's do this particular topic, that is magnetic field at the center and along the axis of a current carrying loop. Now if we have identified a bit of pattern, that okay, that was like this thing, right? If I would have shown you the this thing, that how do you identify the magnetic current through this? If some current is flowing like this, some I current is flowing, how do you identify the current? So what you did was let me just write what you did was you just rotated one of the sides, then curled your fingers along that side, then again you put your thumb on other side, then you curl your fingers. But there is a shortcut. What is the shortcut? Now you curl your fingers along the current. Curl your fingers along the current. So I will curl my fingers in the curl my fingers along the clockwise direction. If I curl my fingers along the clockwise direction with my right hand, what am I observing? I am pointing towards the board. I am pointing towards the skin. If I curl my fingers with my right hand, I am pointing towards the skin. So obviously the thumb will give me the direction of current. So whenever there is a loop present, you just curl your fingers along that loop, and the thumb will give you the direction of magnetic field, and exactly that is written over here as well. You curl the fingers of your right hand in the direction of the current flowing through the loop. Your thumb extended straight points in the direction of the magnetic field at the center of the loop. So there is a proof here. So just a proof that individually, if I just see, current here is flowing upwards. So if I point my thumb towards the current and curl my fingers, it is telling me magnetic field is along this direction, which is shown here pictorially. Now for this right current element, right, current is going downwards, so I will point my thumb on that direction and again curl my fingers. Again it is saying that magnetic field is flowing in this direction. But if I use the shortcut, I will just curl my fingers along the loop. I will just curl my fingers along the loop. If I just curl my fingers along the loop, what I see is magnetic field is going inside the skin, and exactly what is happening. So obviously this technique works. So here in this case, can you tell me, pause the video, tell me where will the current go? So if I curl my fingers along the loop, the current will be going inwards. Okay. So I hope you understand. Due to small segments, all these small segments, not current, sorry, magnetic field is going inside. But if I take the loop as a whole, and if I curl my fingers along the loop, I am observing that current is going inside. Okay, so that is the case here. I hope you understand. So now if you want to find out the magnetic field at the center of a current carrying loop, how do you find out? So this is a case of symmetry, so we can easily find it out. So here I am observing the magnetic field due to a small segment I will be, again, this, what is the direction? This time if I curl my fingers, it is pointing towards me, right? It will be come out of the screen. So all this distance are always r. The distance due to all the small segments are always r. And what about the sine theta? Because what I know, I have to do ideal cross r. Okay, so I know about the direction. So if I just want to comment about the magnitude due to small segments, right? What can I comment? This magnitude of cross product is what? This is I dl magnitude r magnitude into sine theta divided by r cube, obviously. Okay, so here what is happening is that if I just take a small segment in isolation and dl cap is in this direction, right? DL will be in this direction around the tangent, and if I just connect this r cap vector, my r cap vector will be in this direction, right? So I'll just copy this figure. I will just show you one small visualization. I'll just show you one small visualization. And this is my DL vector, correct? So what am I observing is that it is 90 degrees to the R vector, right? And it will be always the case. If I choose this point as well, it will always be 90 degrees, right? It is just a tangent, because this circle is just a tangent to this radius. So DL vector is just a tangent to the circle, so obviously it will always be 90 degrees. So what will happen? I will get this simple equation. This will be equals to mu naught I DL vector will get converted into simple DL I DL divided by R square, because this magnitude and this are same thing only, right? This is R magnitude whole cube. So this will simply become R square, okay? Mu naught I DL R square, and this is my magnitude. So now if I want to compute my whole magnetic field, right? How do I compute my whole magnetic field? I will just, what is varying here? So first I am at this point, then 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 I am at this point. What is varying here? This theta is varying, right? I am varying my theta. I am varying simply my theta. What is DL? DL is equals to what? DL is equals to mu naught I R d theta. You can either say R d theta as my theta is varying, or you can directly say that I am starting from here at L equals to 0 and completing a loop. And what is the length of the loop? 2 pi r. Either way works. Either way works. So I can do both ways. Either you convert into r d theta, or you directly say my length is going from 0 to 2 pi r. So I will do the second case. So I will say dB integration from 0 to b equals to mu naught I by r square. All these are constant. My length is going from 0 to 2 pi r, the circumference of the circle, dl. So this will come out to be yeah, okay, 4 pi is also there, right? I forgot, 4 pi should be there. So this one will come out to be mu naught I by 2r. So this will be the electric field, magnetic field basically of this particular configuration. So if I wanted to find the magnetic field at the center of a current carrying loop which is circular, then basically it will be mu naught I by 2r. You can simply derive it. It will not take you much time to derive. It's very simple to derive, and we will derive this with the help of ampere loop as well. Just similar case only, okay? So I will get the point, and here I have written the expression of the magnetic field. Just remember one thing: if there are n turns, right, n loops of this circular coil with same radius, then what will happen? How much current will flow? So due to this one loop, I have magnetic field mu naught I by 2r. Then again, due to the other loop, again that loop will also contribute mu naught I by 2r. The third loop will also contribute mu naught I by 2r. Like this, I have n loops. So if I have n loops will contribute to mu naught I by 2r. So obviously, overall, what will be my magnetic field? My magnetic field will be n times mu I by 2r. That's it, okay? N times mu I by 2r. That will be the magnetic field due to all the loops, all the n loops. N means the total number of turns in a coil. How many turns I have? Okay, the more the turns, the more the magnetic fields, because I get more turns, more current flows, and due to all those current, they contribute to magnetic field. I hope you understand. Now, with the help of this concept, can you solve this particular question? Pause the video and try to solve it by yourself. So now I will solve. A long wire carrying a steady current is bent into a single circular loop. So we have a single circular loop creating a magnetic field B at the center of the loop. Okay, so I have a single circular loop which creates a magnetic field B, and what is that B value equals to? B value equals to mu. I know mu I by 2r. This I just know. Okay, and this that formula you have to remember. It's easy to remember. If you don't want to remember, you can obviously derive it in seconds. Then, if the wire is then reshaped into a circular loop of n turns, so the wire has been reshaped now with a circular loop of n turns, what will be the magnetic field at the center of this coil? So you will say, sir, wire has been reshaped into n turns, so obviously magnetic field will be n times the previous case, so it will be this option C. Okay, pretty simple, like n terms has happened, so magnetic field also increased to option n times, right? But just sadly this won't be correct. Why this won't be correct? Just you have to take care of one thing. Initially I had a wire, long wire, which I then bent to a circle. Okay, great, right? Great, I bent it to a circle. Then this long wire I bent into n circles. Now the length is fixed, right? This has length of how much? 2 pi r. Initial radius was 2 pi r. That will be my assumption. I will assume it as capital R because that is the biggest radius. Bigger radius, I will assume it as capital R. So let's assume initial radius was r of this initial what I made with a single turn, and it is 2 pi r. So now if I bent it again with n turns, what will happen? That radius will remain same? No, right? The radius won't remain same. Why? Because my overall length of this wire is fixed, that is 2 pi capital R. So if I bend it into n turns, the radius will reduce now. Okay, the radius will reduce because the number of turns has increased, but I have only limited amount of length. So what will happen? I will have n times, what will be the total length of n circles? It will be n times 2 pi small r. The radius of those circles, right, should be equals to 2 pi capital R. Okay, the total length, this is the total length and this is the total length. I'm equating the total lengths in both cases. In the first case, obviously total length will not change. Okay, else the wire, I have to break the wire. So initial total length, final total length. Okay, so what will I get as n? What will I get as R equals to capital R by small n. Okay, R is equals to capital R by small n. So my R is equals to this. Now I can comment on the magnetic field. So initial magnetic field was this. And what do we know? Due to n turns, what will be the magnetic field? Obviously there are n terms, so I will multiply n. Then I will multiply mu naught I. Like they haven't mentioned about any medium. Mu I divided by 2 pi small r, not capital, right? This time the radius of the circle has been smaller because obviously the turns has increased. That is true. Okay, although I cannot show you here because this is a like a 3D structure. I cannot show you exactly. The radius is, just be with me, the radius is same of this particular things. Okay, they are just multiple turns, right? There are multiple turns. The radius of these are same. That is simply r. But what is my r equals to with respect to the previous values? It is r by capital R by n. So this becomes r by n. So this becomes n square mu I by 2 pi capital R. And what is mu I by 2 pi r capital R? Sorry, not 2 pi. Sorry, this is not 2. Simply 2 r, right? 2 r. Okay. So what is this expression? What is this expression? Basically this expression is mu naught I by 2 pi 2r is simply this expression, right? B. So it becomes n square times b. So obviously it becomes n square times r and not simply n. Okay, magnetic field increases further. So these things you have to take care. Just not simply put n b blindly. Okay, so there will be some tricks. Okay, so now moving on with the same theme, I want to calculate the magnetic field due to a circular arc. What will be the magnetic field due to a circular arc? So due to a circular arc, things will be again simple, right? Again I can derive. So this time I will vary my theta. Okay, because deriving in terms of theta will be easier. Again, if I choose one small segment here, this is r, right? And this is dl, direction of dl. So what is the angle? Angle is again 90. So whichever segment I choose, it will be always tangent. So angle will be 90. So obviously my dB will be what? dB will be mu I by 4 pi dl. It is dl cross r. Okay, dl vector cross r vector divided by r cube. I hope you understand why this r cube came, because initially it was r square, but this r vector has its own magnitude as r, so I had to divide on both sides, divide on both sides by r. That's why this r cube came. I hope you understand this one. So now I know the angle is always 90 degrees. So what I can comment here is, this is mu I, this will get converted into dl, this will be r only into sine of 90 divided by r cube. Now here I will replace dl with what? R d theta. That much I hope you understand, that this is my r and this is my dl. So dl I can write as what? Dl can be written r d theta. That's the distance here, right? Simple distance. So I will replace here with r d theta. This will come out to be mu I. Okay, this r gets cancelled, this another r is here, right? So this will be mu I by r, and this will be d theta simply. I have replaced, just hold on, r d theta, that's my dv. So can you tell me what is the total magnetic field now? So obviously I will vary my b from 0 to total b. Direction I will know, just curl your fingers along the current. So this will be mu I, this r will get again cancelled, mu I by r, and theta will vary from 0 to theta basically. So I am varying from here 0 to theta. Overall I am covering a theta angle. Okay, or you can do alpha 1, alpha 2, that whichever one suits you. This will be simply d theta. So your, due to a simple arc, okay, it comes out to be mu I theta by r. Okay, that's the simple formula that I get. Obviously I missed the 4 pi, I'm sorry for that, I missed the 4 pi. Okay, this 4 pi also you cannot forget. And that's why I was thinking, what am I missing? So obviously direction you can tell, right? Can you tell me by just due to this particular segment, in what direction the magnetic field will be? Will it be inwards or outwards? If I just curl my fingers along the current, I am seeing the thumb is going inwards. So obviously it will be simply inwards. The direction of the magnetic field will be simply inwards. So like, let us derive few cases, few standard cases for if I have computed the magnetic field. Okay, then I can derive the standard cases for semicircle arc and for quarter circle. Okay, so here if some I current is flowing, I will use simply the formula of B equals to mu I theta by 4 pi r. So this is capital R, actually here the distance is capital R, so I'll choose capital R. So this will be mu I. What is the theta here? It is total 180 degrees, right? So this will be pi. Remember, theta is in radians here. Okay, don't put theta is in degrees, theta in radians. Just be careful about that. Okay, this one you have to take care, only this part you have to take care. This will be pi by 4 pi r. So this will be mu I by 4r. And can you cross verify one thing? What about for a full circle? What I used to get for a full circle, it was mu I by 2r. If I put here 2 pi, I will get mu I by 2r. So this formula is valid. Okay, you have to check the edge cases. Now for a quarter circle, what is happening? For a quarter circle, the theta, right? Theta here is pi by 2. So if theta is pi by 2, what I will do? I will just replace that. So it will be mu I into pi by 2 divided by 4 pi capital R. So this comes out to be mu I by 8r. So these type of questions can come. Simple, easy questions. You have to find out the magnetic field to do a arc. Okay, and arc can have many cases: quarter circle, half circle, semicircle, or 3/4 of a circle. Anything, right? You can have anything. Now combination of questions can come, because you can have infinite wires and you can have semicircle as well. This is infinite, right? Can you pause the video and try what will be the magnetic fields at point P due to this following configuration? So pause the video and write by yourself. So we will read the question. So a hairpin shaped wire as illustrated in the figure is formed by bending a long current carrying wire. So it is formed by bending a long current carrying wire. What is the magnitude of the magnetic field at point P, which is located at the center of the portion, semicircular portion? So at this point, what is the magnitude of the magnetic field? How do I find out? So again, magnetic field follows superposition just like electric field. So I can simply add individual bits, right? So I can break this down now. So I will break this down into sections. This will be 1, this will be 2, and this will be 3. Okay. So 1 and 2 are semicircular wires, right? Not semicircular, sorry, semi-infinite wires. Infinite wires. Okay. So so what is happening? One of the angle is 90, other angle is 0. So this angle is 90. Okay, other angle is simply 0 as it is going to infinity. And what is the other point that we need to find out? The other point is that we need to discuss is that are they aiding each other or opposing each other? So if I just like curl my fingers along the loop, I'm able to form a loop, right? I'm able to form a loop and it is going inside. So magnetic field will obviously be inside. Okay, I will see simply a cross. But if you want to cross verify, what you can do, individually you put your thumb along the current of the section 1, then you curl your fingers. You are observing that it is going inside. Here it is coming outside. Here it is coming outside. Here it is going inside, right? So here it is going inside. Then again, for the section 2, what can I comment? For the section 2, my thumb will be in this left hand side direction and I will curl my fingers. Again it is going inside for this section. So obviously I can comment that yes, both of them are aiding, so both of them will be added. So either you do it individually or you can totally curl your fingers on the loop and you will find out the like combination of the direction of magnetic field. Okay, so both ways work. So due to semi-infinite wires, what was the magnetic field I used to get? No need to remember any formula, just remember this formula, right? What was the formula? It was mu as they have not mentioned anything, so I will assume it as vacuum. Mu naught I by 4 pi r. R was the distance, perpendicular distance. What is the perpendicular distance? Perpendicular distance is simply this one. What is this? This is simply r, right? Because this is the radius of the semicircle. So this will be r. Cos alpha plus cos beta. So cos alpha is 90. Cos beta is simply 0. And this is for one of the sections. For the other section, the magnitude will be same and the direction will also be same. So I will multiply 2 here. They will be aiding each other. Okay, this is the magnetic field at point P. Now what about for the section 3? What will be the magnetic field for the section 3? So for the section 3, we just derived that it was equals to what? It was simply equals to mu naught I by 4 pi r into theta. Here, right? I just derived here. Correct? So if you want to verify for this particular section as well, in what direction the magnetic field is, you can simply put your thumb. So this current will flow something like this, right? Current will flow something like this. So if current flows something like this, you will put your thumb downwards and then curl your fingers. So you're observing on the left hand side it is going inside, on the right hand side it is going outside. So obviously here it is going inside. So from this one also you can cross verify that it will aid. It will this due to magnetic field, due to this section will only aid the overall magnetic field. So this will be plus, not minus. And anyways, with that like concept of what do you say, curling your fingers along the loop, you are able to say that it is inside only. Okay, so I'm repeating, but I'm just saying this multiple times so that this concept gets clear on your head. So this will be plus, just hold on, this will be plus and this will be mu naught I divided by 4 pi r into theta. This radius is r only, into theta. What is the theta? Theta is simply 180. So pi. Okay, so this will be mu naught I by 4 r. So overall, if I just take common mu naught I by 4r common. Okay, this will be 4r has in common. This will be 2 by pi plus 1. Okay, so is there any option like that? Okay, pi they have taken as common in the bottom. So if I take pi common in the bottom, mu naught I by 4 pi r, this will be 2 plus pi. Okay, so your option C will be correct. So this question is good. This type of question can come in the examination. And can you talk about the direction? So direction is going into the screen. So according to this, the xy plane is here. If it is going into the screen, right, it will be in the az cap direction, in the minus az cap, because positive az cap is here, minus az cap is there. So it will be in the minus az cap direction, or I can say going into the screen. If it is going into the screen, I am seeing the behind of arrow. So it will be simply a cross. Okay, that's it. Now let's do next question. So this type of question will come and I will solve this type of question. This type of question I am hoping that they haven't yet asked this type of question, but this type of question can come in the future. What is the magnitude of the magnetic field at point P, which is located at the center of the semicircular portion? So again, I have two semi-infinite wires and this is a semicircular portion, and this time like they have given me proper coordinates and the configuration is a bit different. So still I will be able to compute, right? So I will just copy this particular thing and write that. Again here, are you able to observe? Are you able to observe here that this is semi infinite wire, right? So what coordinate is varying? Here my x is varying. Okay, sorry, my okay, this which coordinate is varying here? Sorry, not x, y is varying, right? Y is varying. So this has the equation of r comma 0, not r comma 0, r comma y comma 0. Okay, this r and 0 are fixed, y is always increasing, y is always varying. Now this has the equation of what is fixed? This has its y as 0. Okay, y, how is it 2r actually? This should not be 2r. Okay, something is missing. This should be 2r, right? Something has went wrong. This should be 0. This should be 2r. Yeah. So can you tell me what is varying here? So here my x is varying because this 0 and 2 are fixed. This is always lying in the xz plane. Okay, it is always lying in the xz plane. So if it is always lying in the xz plane, my 0 like y equals to 0 and z equals to 2r, these two coordinates are fixed. Just what is varying? My x is varying this time, x comma 0 comma 2r. So with respect to this point, what is the location of this point? The location of this point is simply here. If I observe, this distance is r, right? So this all, I like from this place I can observe that the perpendicular distance will be r only. From here also the perpendicular distance will be r. But where is this point located at? This point is located. This is a straight line, right? This also should be r. Yeah, this also should be simply r. If this is r, right, then this will be a problem actually. This point I can say anything right now. Let's assume it to be 2r comma y has to be same and x, z has to be also same, right? Yeah, z is also 2r. Yeah. So actually this point is what? Can you tell me, comment about this point? This point is lying at the center of this and this is a straight line. Okay, this is just a straight line. So the coordinate of this point will be, this here is, this is r. Yeah, this is 2r. Yeah, this will be, okay, one mistake I've done. This is not, this r only. Okay, r comma y. What is y? Y is simply y is 0 actually, and z is r only. Yeah. So like how am I able to write this thing? So basically like the question is a bit flawed because the drawing is not perfect. If this is r, right, if this is r, then this should actually touch the y z axis, but don't go into the drawing now. Just go into the concept. Just because this is a straight line, so here, right, what is same here in this case, basically the x coordinate must be same, so everything should be r here. Okay, x coordinate must be same. That's how the drawing is, that's how the point is. Okay, now can you like from here I can observe, yeah, this is the perpendicular distance, simply simple r, right, radius of the circle, and this is also the perpendicular distance, simple r. But if I didn't tell you this, okay, if I wasn't able to visualize, just vectors were given, how would I have able to find out the perpendicular distance? What you would have done, you would have made this x coordinate same for everything, right, because here x is varying. So you would have made x same for these 2 points. What is the x for this? R. So this will be also r. Now how do I find out the, let me name few points, A and B. So what will be my BP? That will give me what? That will give me the r vector for this particular segment. Let me name this segments. Let me name this segment as 1, 2, and the semicircular is 3. So the first segment, okay, for this first segment I can comment BP vector will be what? Like I know already the answer, I can solve it in 30 seconds, but I just wanted to explain it a bit more. That BP vector is what? BP vector is pointing outwards, right? So it will be OP minus OB. And what is OP? OP is R AX and RAZ. Okay, so I'll directly compute this thing, particularly this thing. This will be equals to, x coordinates will be same, R minus R AX. Now y coordinates, they are 0 in US, so it doesn't matter. What about the z coordinates? So it is final minus initial, so it will be in this direction, right? So it will be R minus 2R AZ, and it makes sense basically. So here it will be minus R AZ. Does minus R AZ make sense? Yes, because my vector will be pointing on this direction, which is in the opposite direction of the positive z axis. So it is making sense. So all this I can solve in seconds, okay? But why am I showing you this? Because you are able to visualize as well, and one day when this picture won't be there, you have to directly write down the vectors, solve using vectors. For that day I am preparing you. Okay, so now for the second section, what will happen? For the second section, simply here, this is the final and this is the initial. Again it will be BP, not BP, AP equals to, like before going here, right, I just wanted to write down the unit vector of AR1. What will the unit vector? It will be minus AZ cap. Okay, what about AP? AP is what? AP is final minus initial, that will be OP minus OA. So it will be equals to, again the x coordinates must be same. X coordinates must be same. Not x coordinates this time. What must be same now? The y coordinates must be same. Why? Because the y is varying. Here in this line the y is varying, so y coordinates must be same. X can be different as well. X and z are already known to me. Okay, x and z are already known to me. So x, this is R minus R AX plus, this will be y coordinates must be same. So this will be 0 always. This is 0. Y should also be 0. So 0 minus 0, y coordinates must be same. What about z coordinate? Z coordinate is R minus 0. Okay, so if I just take the page, so my AP vector will come out to be R, this is AZ, right? AZ. Okay, and does it make sense? Let's see, does it make sense? Yes, right, it makes sense because I'm coming from here to here and this is pointing towards a positive z direction. Don't go into the drawing, this drawing is not perfect, but just try to understand the feelings. So it is coming towards the positive z axis, so yeah, it is correct. And what is the unit vector for the section 2? It is simply AZ, right? Just divide by the magnitude. So here, what about this particular thing? semicircle. Again, do I need to find out the semicircle? No, right? I can directly compute. Okay, you can directly compute what is the direction. So the current will flow something like this. So if I curl my fingers along the wire, I'm observing it is pointing downwards. Okay, it is pointing downwards. So it will be in the minus AY cap direction. Okay, the direction of the magnetic field will be in the minus AY cap direction. So this you have to identify. Can you identify the direction due to this? So if you do dl cross r, so I will do dl cross r for each of these. So here for the section 1 and 2, the dl cross r will give me what? Dl cross air cap will give me the direction. I can directly say as well with the hands, but I will cross verify this. So dl cross r. So what direction I'm getting? This should be AR1. Okay, dl for this case is what direction? It is in the negative x direction, right? Negative x direction. So this will be minus ax cap cross minus az cap, or ax cross az. This will be equals to minus, I will just choose another color, minus ay cap. What about this case? Here again, what will be my, this is the direction of the magnetic field. Here, what is my direction of the magnetic field? It is dl cross AR 2 cap. Okay, so dl is what? In this case, dl is what? dl is in the plus ay cap direction. So it will be ay cap cross az. It is in the plus is ax cap direction. Now is this correct? Let me cross verify this, right? Now let us cross verify. So due to this particular thing, I'm observing, I will just put my thumb in the direction of the current and curl my fingers. I'm observing it is going downwards, that is in the opposite of positive y-axis. That's why I got here minus ay. Correct. For the section 1 I'm talking about. For the section 2, I will put my fingers along the direction of current, which is along plus ay, and then I will curl my fingers. If I curl my fingers along this, it is showing me that it is along this direction. What is this direction? Plus ax cap. This is in the positive ax direction. So both of them are correct. For the third case, I will not use the cross product, just will be hectic. If I just simply curl my fingers, right, along the loop, what is the loop? This loop, right? If I just curl my fingers along the loop, it is in the minus ay cap direction. So this direction will be minus ay cap. So this is AB1, AB2, AB1, and for the third section, AB3 will be in the minus ay cap direction. Now directions have been found out. I am taking so much time just to explain, okay? It won't take you much time to solve. So now I know the directions. I will just put this thing right in this page, that will be better. Now what about the magnitudes? Okay, what about the magnitudes? Magnitudes are simple, right? For a semi-infinite wire, what was the magnitude? For a semi-infinite wire, the magnitude of B1 will be simply mu naught I by like one of the angle is what? This is on the perpendicular, right? So this one of the angles will be 90. You can again compute that with the help of the tan formula, but I can directly observe here that this will be 90 degrees, right? As it is 90, so it will be simply 4 pi distance r, right? What is the distance? That r, and cos 90 plus other distances, other angle is 0. So cos 90 plus cos 0 is mu naught I by 4 pi r. Here as well the same thing, semi-infinite wire, and this is the angle, right? What is this angle? This angle is again 90 degrees. So this will be B2 will be mu naught I by 4 pi r. Okay, capital R. I will not write here vector format because this, okay, I can write vector as well, the magnitude with the magnitude. So what about the third section? So in the third section, if I just want to comment on the magnitude, it will be mu naught I by 2 pi capital R into theta. So what is theta here? Not 2 pi, sorry, 4 pi into theta. So theta is, in this case, this is a semicircle, so it will be pi. So this will be mu naught I by 4R. Okay, this is the magnitude. Now I can sum all this, right? I can find out the B net. What will be the B net? It will be B1 plus B2 plus B3. Okay, sum of all the three sections. So for the first section, it is in the minus AY cap direction. This is also in the minus AY cap direction. Okay, so these two will get added simply. So it will be mu naught I by 4 pi R plus mu naught I by 4R. Mu naught I by 4R, and take pi common as well, 4 pi R. It will be pi plus 1 in the minus AY cap direction plus mu naught I by 4 pi R in the plus AX cap direction. Correct. So what will be the magnitude of my B net? Because they have asked in the question magnitude of B net. So your magnitude of B net will be mu naught I by 4 pi R will be at the outside. This will be pi plus 1 whole square plus 1 whole square whole under root. This will be the magnitude, right? And in the, like, the initial question was wrong. Actually option should not be there. In the next question I have framed a similar the actual question which was supposed to be there, because some sort of typo has been made, but it's okay even if the typo is made. But we solved a very difficult question because this is one of the difficult questions. Okay, so I hope you got all these points. Please repeat, go over it go over it again if you couldn't understand this. Okay, now let's try to understand this, right? This is the same question, but here the lines have been changed a bit. Okay, this line has been changed. Now I will do this fast. I will do this fast because I wanted to show you how to solve in the examination, because in the examination you will be using this method, not the previous method, because that is very lengthy. So here what I will do, I can directly comment what is the, like, I will just tell you the direction right now. Okay, let me break it down into sections 1, 2, 3. Now if I curl my fingers along the one, right, like if I put my thumb along with the one current element, one section, okay, then I curl my fingers, it is going inwards. So due to AB1 will be what? AB1 cap will be minus AY cap direction. Due to the second, I will again, this is a loop, so I will curl my fingers along the current direction. Current direction is in this direction. Okay, in this direction, so I'll curl my fingers, then I am observing my thumb is pointing in the minus AY cap direction. So AB3 will be minus AY cap direction. Okay, just let me write this properly. AY cap direction. What about 2? Is it even contributing to any magnetic field? If I put my thumbs and curl my fingers, yeah, it is contributing, but where is it contributing? So if I just extend its axis, right, although this is not to scale, but if I want to put it to scale, please bear with me, just put it back to scale. Okay, if I just put it back to scale, it is along the axis, although it is like you're feeling that it is not along the axis, but let's assume the center point to be somewhere around here. Okay, it is along the axis. Okay, it is along the axis. So B2 will be simply 0. It will not contribute to any magnetic field. Why? Because it is along the axis, and along the axis, can you define the direction? If I just this is a straight line, right? Although this is not looking like a straight line, just trust my words. Okay, because the drawing is not perfect, I am not able to show you perfectly. This should be a straight line actually, like this. Okay, and this also should be a straight line like this. Yeah. Okay, just trust me that this is a straight line. So if this is a straight line, right, so this wire will not contribute to any magnetic field, so I don't need to contribute any magnetic field due to this, so I can just ignore this thing. Okay, so only magnetic field is present due to these two. So what is the magnetic field? Basically both are in minus a by cap direction. What is the magnitude of B1? Semi-infinite rod, right? And the point is at one of the ends, so it will be mu naught I by 4 pi r, and again due to this also it is mu naught in theta by 2 pi r, which is pi, mu naught into theta by 4 pi r, which is pi in this case, so it will be mu naught I by 4 r. So obviously my B net magnitude is mu naught I by 4 r 1 by pi plus 1. And if I want to comment of the direction will be in the minus a by cap direction, and according to this it will be simply option C. How is this option C? Okay, I done something semicircular arc, right? 4r, okay, not option C, sorry, option A. Okay, just this side, 1 by pi plus this, yeah, option A. So yeah, that is fine. You in the examination all you solve it like this directly. You know the formula, you put it, you find out the direction separately, then you add these two up vectorically. Now can you tell me what is the direction of this particular line here, right? What is varying? It is varying along the z direction. So z will be variable, other two things will be fixed. Here this is varying along the x direction, so x will be variable, other two things will be fixed. Okay, so from here you will be able to find out the perpendicular distance, you will be able to find out the angles if this is not lying on one of the ends and somewhere in between here. Okay, so I am just preparing you for the difficult questions as well. So I hope you understand the answer to this question will be simply A. This will be the solution. Okay, so now let's solve another question. This is a good question again. So here what is the magnitude of the magnetic field at point P, which is located at the center of the semicircular portion? So here I have two circles, right? Two semicircles. So how will I find out the magnetic field? Again, remember there are how many segments? You will say there are two segments, these two semicircles. No, there are not two segments. There are 4 segments. Okay, I will just now I will do this quickly. So there are 4 segments. What 4 segments are there? You are correct. 2 semicircles are there. Yes, this is the one segment. This is a segment 2. Okay, 2 semicircles. This one of the semicircles, one other semicircle. But this is also a segment, right? This is also a segment. Due to this also some magnetic field may get contributed. I don't know, but it may happen. This is 3 and this is 4. But what observation I am observing? If I just put my fingers along the current direction and just curl my fingers, right? I am observing this is exactly lying on the axis of the wire. This is lying on the axis of the wire. So obviously this section 3 will not contribute to any magnetic field as it is lying on the axis of the wire itself. Same case for the 4th segment. It is lying on the axis of the wire. Again, the direction at top of P will be going inwards, direction at bottom of P will be coming outwards towards me, but exactly at P there will not be any magnetic field. So magnetic field here due to these 2 segments will be 0, but this and this has some magnetic field. So I will write here B2 and not B2, sorry, B3 and V4 will be simply 0. Magnetic field like point lying on the axis, correct? What about B1 and B2? So B1, again, I will just curl my fingers in the loop now. I'll curl my fingers in the loop. It is going inside the screen. And if I curl my fingers along the loop, so here observe it is on the right hand side. This current direction is on the right hand side. And this current direction, right, will be on the left hand side, correct? So they are in actually opposite directions. If I observe, this is going inwards due to the bigger segment, that is segment 1, and if I curl, this is in the opposite direction, it is coming towards me. So obviously I can directly say that B1 will be, I can directly write the magnitude. What is the due to the semicircle, what is the value? There is mu naught I by 4 R, and it is coming outwards. Okay, coming outwards, not coming out, sorry, going inwards. So this will be cross. Okay, and remember this is 2R actually, this is not simply R, this radius is 2R, so we'll write here 2R. And B2 will be what? mu naught I, current is same only, divided by 4 into R. And if I curl my fingers, I am seeing the thumb is pointing towards me, so it is coming outwards. So these two are in opposite direction. Okay, so if these two are in opposite direction, so my B net, which one is bigger? So this one is bigger. Why is this one bigger? Can you justify this? This wire is lying nearer to this point, so obviously the influence of this, the magnetic field due to this wire will be higher. As the currents are same, distance is slower for this, obviously the magnetic field influence due to this wire will be higher. So this will be mu naught I by 4R minus mu naught I by 8R. So this will come out to be mu naught I by 8R. Which direction? Coming towards me. This is coming towards me, right? Because the inside circle has greater influence of magnetic field. So this will be coming. Why this doesn't make a circle? I don't understand. Yeah. Towards me. Okay. So this will be mu naught I by R 8R. This will be the answer. Okay. And like, although you can mention here as well, it is in the plus AZ direction, coming out of the screen, or in the plus AZ direction, because this direction I can say, what is this direction? This is going into the screen, so this will be in the minus AZ cap direction, and this is in the plus AZ cap direction. So overall this will be in the plus AZ cap direction. Okay, I hope you get the point. I have told you the direction coming into the screen or out of the screen, and the magnitude as well. All those things have been mentioned. So this will be the solution for this particular question. Now let's come to another derivation. At starting itself, I will tell you that this is not that important, and most educators don't tell you this formula. Like, they just tell you the formula and that's it. I will try to derive in front of you. Okay, but I will tell you at the starting itself that this is not that important, because the formula that will come, you have to remember that formula. Then the derivation is also tough. And my prediction is they will not ask a question from here, but it's my duty to teach you everything. So we have found out the magnetic field at the center of a loop. But what about if the point is lying on the axis? Just see, as the same case, the magnetic field lying on the axis of a ring, right? For a charge, ring charge. If you remember, electric field, not magnetic field, sorry, electric field. Same thing I will do here. Yeah, sorry, I had to pause the video because some background music is playing, but unfortunately we have to continue because we are just at the finishing portion. So here mainly what I wanted to raise a concern is that I have 2 points, right? I will take two diametrically opposite points, and if I just take the cross product, I know that DL vector and R vector will always be perpendicular to each other. Why? Because this is on some other plane and this is the DL vector, right? And as it is tangent, right, this will always be, whatever point I will choose, DL and R vector will always be perpendicular to each other. So if DL and R vector are always perpendicular to each other, so I can directly write down this formula. What is the formula? So here also you can observe that AR2 and your DL vector will always be perpendicular to each other. So I can directly equate this mu naught by 4 pi I DL, like this will be magnitude of R vector sine 90 divided by magnitude of R whole cube. Okay, so another important point is I can observe that the magnetic field, like due to this point, will be somewhere along this direction. If I take the R cross L, okay, just simply take the R cross L, you will get the magnetic field R cross L. You will get the magnetic field like this. Now here, right, the magnetic field will be somewhere along this direction. So that is what I am showing. This is dB and this will be some dB dash here, that will also be theta. So mainly the magnetic field will be contributed due to dB cos theta, and dB sin theta components will cancel each other out. Just the same case as the ring charge. Okay, just the same case as the ring charge. So obviously what I will write here, so my small magnetic field dB will be mu naught 4 pi IL IDL by R square. Okay, so this is ideal. Okay, So like here also I've shown you the same visualization. So the magnetic field due to this, right? If I do dl cross r, I will get a vector that will be perpendicular to both of this. Now here also, if I do the same dl cross r, what will happen? I will get a vector here. Okay, so I will get a vector here that I will get. Okay, so this will be db dash. Okay, so and this angle is theta, correct? This angle is theta, and if this angle is theta, what can I comment about this angle? This angle will also be theta. Why? This is 90, this will be 90 minus theta. Okay, this will be 90 minus theta, correct? So this overall is 90 and this is 180, right? If this is 180 and this is 90 minus theta, so overall this angle should be theta, right? Sorry, 180. So this angle is whole 180. So 180 minus 90 minus theta will be simply give me as theta. This angle will give me theta because this is 90. So okay, just hold on. This is 90 minus theta. Like I'll just prove it to you. Just let me name this some random angle. Okay, let me name this some random angle alpha. Okay, if this is alpha, this angle will be how much? This will be 90 minus alpha, correct? And this is already 90. This is already 90. If this is 90, then what about like what is the relationship? If I add all this three up, I will get 180, right? So 180 equals to 90 plus 90 minus alpha theta. So like what happens? This 90 gets cancelled. Alpha equals to theta. So I get alpha equals to theta. That is here, right? Alpha is theta. So I hope I have proved it to you. Alpha is equals to theta. And I know this thing that all the three vectors will be perpendicular to each other. Basically my db vector, like I know all these things, right? Already that db vector will always be perpendicular to my dl vector and always will be perpendicular to my r vector. That's the definition. That's in the simple definition, right? So what is the main point I want to talk? So only the magnetic field will be computed due to db dash. What is db dash? Db dash is simply db cos theta. Okay, due to that component only magnetic field will be computed. So what is cos theta here? What is cos theta? Can I say what is cos theta? R is the small distance, right? And this will always be, magnitude will always be constant. R won't change, right? R magnitude R won't change. Okay, this will always be constant. This is not varying. This capital R is also not varying. What is varying? Okay, I will show you what is varying. So cos theta is what? Cos theta, sorry for that. Cos theta is simply small r by magnitude of small r by capital R. What is varying? This x is varying. If I move up along the axis, because I want to find out the magnetic field along the axis, so I will write this in terms of x. Okay, sorry, I have made this mistake. This is this cos theta, right? Sorry, this space will be in the bottom. This will be r. I'm sorry for the music if you are able to listen to the music. So it's somewhere beside my room, so and I can't tell them to turn down the volume. So this will be r divided by x square plus small capital R square, right? Capital R square whole 1 by 2. Okay, so this is the cos theta. So now if I replace everything, right? If I just replace everything, what will I get? So my db dash, that is my db net actually. db dash, this is small db is how much? Mu naught I dl divided by, sorry, actually x is also not varying here. I'll just show you what is varying. I dl by 4 pi by r square. What is the r square basically here? I can replace the r square, right? What is r square? I want to replace r square in terms of r and x, because r and x will be given in the question, r square won't be given. So what is r square basically? R square is capital R square plus small x square, right? That is my r square, right? You can say r square equals to capital R square plus small x square. So this will be x square. Okay, and cos theta is obviously there. This will be r divided by x square plus capital R square 1 by 2. Okay, so what is varying? Tell me. Same thing as the electric field, right? What is varying here? I told you, yeah, x is variable. If I move along the axis, x is varying, correct. but here I'm going along this DL direction, right? I'm going along this DL direction. X, yes, X is variable if they want to ask at this X equals to 1, X equal to 2. But for now, they have asked at certain point, let's say X equals to 1. At X equals to 1, they want you to find out the magnetic field. What will be the magnetic field? I have to sum all these points, right? I have to sum all these points. So I will go along this whole direction. Now, what is this distance? Okay, this is from X equal to, DL equals to 0 to L equals to 2 pi r, this whole circumference. This X is fixed, right? This X is fixed. So I will go from, to get the whole magnetic field 0 to B net, I will go along the whole path. So this mu naught R I 4 pi X square plus R square 3 by 2, all of this is simply constant, because this X is from what is the distance of that axis, right? Along what is the height about which I am able to, they are asking me to compute the magnetic field. So this will be integration dl, only simple dl is there. I'm going from 0 to what? To this whole circumference, right? Through this whole circumference I'm going, just I need to find out the magnetic field at a height x about the axis of this ring. Okay, x is constant, capital R is constant. What was changing? This was changing, right? I was going along this wire to find out the individual magnetic fields and add those up. So I'll go from 0 to 2 pi r. So your dB, your B net will come out to be what? B net. Okay, this is, I'm computing along the about the vacuum. So I just remove the mu naught because I want to talk about general case here. So I will just remove the mu naught, else you will get confused. Okay, so your B net will come out to be what? This will be equals to mu I divided by x square r square 3 by 2 into 2 pi r, right? So 2 pi, this will give me 2, r will be still here, this will be r square. Okay, so and the direction will be along a b cap direction, that you need to find out. Just rotate your fingers along the direction and you will be able to find out. Okay, this is a neat expression. It's good if you are able to remember. Okay, it's not possible for you to derive, but I hope with the derivation you get the slight idea how it is working, right? And let's do a case, edge case. Let's do a edge case. Let's do sanity check. If I put x equals to 0, what does that mean? That means I am at the center of the ring. If I am at the center of the ring, what should be the magnetic field? It should be mu naught I by 2r. I will put x equal to 0. What do you get? This is simply r cube. So r square by r cube, this cancels out, and this is mu naught I by 2r, which is correct. Okay, so at x equals to 0, I am getting a correct expression, right? So you can check by putting x equal to 0. Okay, so it's good to remember. If you are able to remember, that's good actually. Okay, but if you are not able to, that's also fine, but I will recommend you to remember. Just remember that what are constant? R is constant, right? Radius of the ring won't change. The axis, the distance from the axis about which I have to find out the magnetic field, that won't change. Just what is varying? I'm going along this axis. Okay, that's all that is varying. Like, I hope you understand this point. Okay, so that was the main thing. And this theta, right? This theta angle. What was the theta angle actually? This dl cross r. What was the theta angle? The angle between the dl and the r vector. So just wanted to I wanted to quickly recap this whole thing, how I derived it. Okay, so first thing is, if I observe this visualization, right, I can observe that always the dl vector and the r vector are always perpendicular to each other. The dl vector and r vector are always perpendicular to each other. So that made my derivation much simpler. Okay, because it is perpendicular, so this will always be sin 90. Okay, so I have to just take care of the magnitude and the dl, the vector component gone. Okay, now this becomes ideal by r square, correct? Now if this becomes ideal by r square, what I am doing, I am observing that at the both diametrically opposite points, there is some cancellation going on, there is some symmetry going on, same as electric field. That's why I am going here fast, because I have explained the electric field very well. Okay, so what will happen, this dB and the other dB will get cancelled. Okay, the sine component will get cancelled, only the cos component will be remaining along the axis of the loop, along the axis of the circular loop of the ring, the cos component will be remaining. So that's why I broken it down to cos theta, and I have proved to you how this alpha angle became cos theta. So the magnetic field will be only due to dB cos theta. So you will say, sir, x is varying, x is not varying, x is constant. What is varying? I am going along the dl vector, right? I am going along the dl vector and adding all the magnetic fields. So I am going along the circumference. So the dl will go from 0 to 2 pi r, and this through this I will get my formula as b net as mu naught I r square divided by 2 into x square plus r square whole raised to power 3 by 2 a b cap. Okay, this also makes like you can check the dimensions, is it dimensionally correct or not. Okay, so this is the formula, and direction I hope you know, just curl the fingers. Okay, for direction, curl your fingers. Okay, so let's solve one basic question with the help of this. So if the magnetic field intensity at a point on the axis of a current carrying coil is half of the intensity at the center, so at the center there is some intensity b center, sorry for the like music, so we have to stop. This will be b by 2, and magnetic field at a distance at a point is half the intensity at the center of the coil, at a point along the axis. So let's say this is at a distance x, right? At a distance x, the magnetic field is, sorry, this is b only, and this is b by 2, b center by 2. Okay, so what are they asking? What is the distance of that point from the center of the coil? They are simply asking this x distance. How do I compute? So I have to again compare the expressions. So what is b equals to? B equals to mu naught I by 2r. For a center, I know the magnetic field for a center is b naught I by 2r, right? So what about the bx? I have just derived the formula. It is mu naught r square divided by x square plus r square, x square plus r square, and obviously there is 4 pi, don't forget there is 4 pi here. Sorry, there is 2, right? There is not 4 pi, sorry, there is, because 2 pi gets cancelled. I remember, that's why I derived in front of you. Few things you will remember. Okay, the 2 pi are at the top and the 4 pi gets cancelled, so this will be bottom 2. So that's how you recall the formula. So this will be mu naught I by r square, x square plus r square. So here this is equals to b by 2, that is, it is equals to b by 2. This is equals to mu naught I by 4r. So now from here I will equate the things. So this will be r cube, 4r cube, and okay, this is 2r, yeah. So 2 gets cancelled. Okay, this is 3 by 2, correct. So here this will be x square plus r square (3 by 2). If I just okay, anything am I doing here wrong that I wanted to check quickly? This will be mu naught I by 2r. If I put x equal to 0, yeah, this is mu naught I by 2r only. So if I just under root cube this, so this will be 4 by 1 by 3 r, and I have to square this again, right? What I will do is I will square this. This will be 2 by 3 r equals to x square plus r square. This is square actually. So here my r square is 4 2 by 3 minus 1 equals to x. Now x square, I will take the under root of this thing. X under root will be r 4 2 by 3 minus 1. Okay, so it will be, why is it 1 by 3? Am I doing something wrong? This is 1 by 2 only. Just wanted to quickly check what am I doing wrong here. So Okay, this should be only 2. Sorry, this should be only 2, right? Yeah, I missed the point. I've cancelled 2, so this should be only 2. So I will just square this, then I will take the under root. So this will be 4 raised to power 1 by 3. This will be 1 by 3 only. So I hope you understand the calculations. So calculation part I won't explain much. Okay, 1, and this should be 1. Okay, this is a good question. So like I will just quickly go through the question once again. So they are telling that at the center of the coil, the magnetic field is some B. Okay, and at a distance x from the axis of the coil, the magnetic field is half the center of the coil. So it will be B by 2. Okay, now they are telling me what is that distance where it will become half. So they are asking me the distance. Okay, so what I have to do, I have to equate the two things, right? First of all, what is the magnetic field at center? It is mu naught I by 2r. What is the magnetic field at a distance x? It is mu naught I r square divided by x square plus r square whole raised to power 3 by 2 into 2 is also there. Okay, so we'll equate this with b by 2. So that will become mu naught I by 4r. I just missed a extra 2, cancelling extra 2 here. So that's the mistake. So if I cancel 2 on both sides, this will be 2r cube, and on the right hand side I will have this expression. Now what I will do, I have to remove this, right? This radical term. So what I will do, I will first square it, then cube root it. So if I square it, this will become 4 r raised to power 6. Then if I cube root it, I have to divide this 6 by 3. So this power will become 2. I have to divide this 4 raised to power 1 divided by 3. So that power will be 4 raised to power 1 by 3. I will not explain calculations here. Okay. So this will be 4 raised to power 1 by 3 r square. And now what I will do, I will take the r square common. If I take the r square common, x square will be this, but I have to find x. So I will take the whole under root of this whole expression. So this r square, if I take under root, this will be r. And this whole expression, if I take the under root, this will be 4 raised to power 1 by 3 minus 1 whole raised to power 1 by 2. Okay. This is a good question. This is a maximum level that they can go. Okay. So you can go through this question again. And yeah. Here I've written just the variation. Once the variation, you can go through how the magnetic field is varying. So there can be two ways the magnetic field can vary, because they can ask you the plot graph as well, right? So obviously I am observing as I am moving further away from the origin, from the center, the magnetic field will reduce. That is intuitive as well, right? The further away, the strength of the field lines will be reduced, and obviously the magnetic field will also be reduced. But there can be two cases here. The magnetic field can reduce like this. The magnetic field can reduce like this. Okay. Which one will I follow? Will I follow this or this? You will say, sir, I will follow this one. You will say, because it should change slowly. Like there should be some continuity. This is looking like a the derivative doesn't exist right here. So there is a sharp change here. The function doesn't seem differentiable, but magnetic field must be differentiable. Okay, but you should verify that as well. You should explain that as well, like mathematically. How will you explain? Just find out the derivative of this. So because there can be two ways, because in the options they will give you 4 options. Okay, and one option will be this graph and this graph. How will you differentiate? Or let's say for some other graph, how will you differentiate for some other characteristics, magnetic field characteristics? How will you differentiate? What do you do? You take the differentiation. Okay, if I differentiate with respect to x, because here obviously my x is varying, right? My x is varying, so I will differentiate with respect to x. If I differentiate with respect to x, obviously mu naught I by 2, all these are constant, r square is also constant, into what is happening? This will become square. I hope you understand how to differentiate. This will become whole square, whole cube, and at the top, what I will have this power will come, right? First of all, this power will come, that is minus 3 by 2. Actually, a bit of mistake I have done. This will be n minus 1. So this will be 5 by 2, and inside I have to differentiate chain rule 2x. Correct? So this will be the simple differentiation of this. Now the important point that you have to understand is, if I put here x equals to 0, if I put this x equals to 0, what am I getting? X equals to 0, this function goes to 0. So at x equal to 0, my differentiation should be 0. That is, my slopes will be, what does 0 represent? What does slopes equal to 0 represent? It represents slope parallel to the x-axis. So obviously here the slope is telling that slope is very high, but this graph is telling slope is 0 parallel to the x-axis. So obviously I will choose this graph and not this graph. Okay, I hope you understand the difference. And trust me, one day they will ask you this graph question. Tell me, how is the magnetic field varying if I change my position x? And you will not be able to identify the difference. Like there can be two cases. Obviously it will reduce. If I put x equal to infinity, it will reduce. But how it will reduce, that also you will be able to identify with the slope. Okay, so the the variation will be something just like this, not exactly, but I hope I'm able to draw it perfectly. And at center, what is the value of the center? It is mu I by 2r. This is the value of the center. Okay. So I hope you understood all these points, and that was about it for this lecture. One small thing that I wanted to say, this is also not that important, but just in case they tell you this term, you are not scared, so I have to explain this term. Not that important, I will say. Okay, just in case if they talk about this term, you have to know this term. Okay, this thing, right, this also we equate this with mu naught by 4 pi. This is a constant, I hope you remember, into 2m vector by x cube. Okay, x is the distance basically. What is this m vector? This m vector is the magnetic moment, same as the electric dipole moment. This m vector is called as a magnetic moment. That's it. Okay, this is just a theoretical point. And what are dipoles in magnetism, electromagnets? Basically, they are north and south poles. These are called dipoles. Okay, they cannot exist singularly. So north and south pole, what happens is, if I have a magnet and the magnetic field lines are something like this, you know already this, right? You already know that magnetic field lines of a electromagnet or a bar magnet is something like this, and we call this a dipole. We call this a dipole. Now, these type of field lines, right, actually get produced by the circular coil as well, circular ring. Okay, circular ring. So that's why we call this also a dipole. Okay, as magnetic field lines similar magnetic field lines. Okay, as we have similar magnetic field lines, we call this as also as dipole and this also as dipole. Okay, so the important point is, if we call this as dipole, a dipole has to have its own moment, so we equate that with dipole moment m vector, that is known as dipole moment, and this is the equation for it. So if you ever want to find out the dipole moment, just equate these two equations, magnetic moment, you just equate these two equations and you will be able to find out magnetic moment. Here x cube, okay, I have made this a mistake, this should not be x cube, sorry. Okay, one thing is there, like how is this x cube actually? This actually is x cube. How is one more point is, if my x is very larger than r, so I'm observing my r is here and I'm observing very further away. Okay, so obviously this r distance is very small. R square plus x square will almost be equals to x square only, so this will get converted into x cube. So now I can cut these two things, and from here I will be able to find out my magnetic moment. Okay, so this equation you should know. How to memorize this equation I have also told you. Just equate with the magnetic field intensity along the axis of a coil, circular coil. Okay, that's basically it for this lecture, and don't have to worry about this too much. Just have this in a short notes and that's it. Once in a while revise. So that's basically it for this lecture, and this lecture was very long and we learned a lot of concepts, we did a lot of questions. So if this lecture was a bit heavy, please go through your notes again and try to solve by yourself. Only once you solve by yourself, the concept will be cleared. Only I solving in front of you, that won't be of much use. Okay, so from the next lecture we'll study about magnetic force. How does a charge actually, if it is present in a magnetic field, how does it get how does it feel a force? How does it feel a force? Just like same as electric field. Okay, so thank you for watching and I will see you in the next lecture. Until then, happy learning.